Hello students, welcome back, and this particular video is covering material in Lesson 4, which is covering Chapter 4 in your book titled How to Use PHP with a MySQL Database. This chapter really brings together everything we've talked about so far. The PHP, the HTML, the SQL, the database theory, all of it comes together in this chapter as we build a web page that communicates with a database and reports data back through PHP into HTML through the browser. So all these technologies fit together and work in the examples in this chapter. Everything from this point forward in the book and in the course really are specific dives into areas of technology related to PHP or SQL or MySQL, but this chapter really is the linchpin chapter of the semester because it really presents to you the capabilities that you have at your fingertips with all of these technologies. So with that, I wanted to just talk about the two programs in the chapter, the Product Viewer application and the Product Manager. In this first video, I just want to talk about the Product Viewer, and I'll save the Manager for the next one. So what we've got here is XAMPP, and as you can see here, I'm running Apache and the MySQL DBMS engine. So they're both running, lights are green, so I'm going to minimize that. Then the next thing I want to show you is in your folder of your files for the textbook. If you go into the Book Apps folder, you'll notice there's a Create DB subfolder. And in there, you find 3 SQL files. In the book, they use 2 databases, My Guitar Shop 1 and 2, and the CreateDB file creates them both. So the first thing you want to do, if you haven't already, is to run that file. When I say run it, I really mean to import it into phpMyAdmin and run the script inside of it. So what you want to do is you want to go back over to your web browser and go into XAMPP by typing in localhost. It should bring up XAMPP by default. And then what you want to do is click on phpMyAdmin, which takes you here. And if you look at the databases on the left, you'll notice these are the standard databases that install when you put in XAMPP. Now, what we want to do is we want to be at the server level, localhost here, and you want to go over to the SQL tab. And what you want to do, I'm sorry, that's the wrong tab. I'm sorry, you want to go to the import tab over here because we want to import the SQL file. This tab, SQL, we'd have to type it all in by hand. We don't want to go there. We want to go to import. What you want to do here, right where it says browse, you want to select that button and you want to point it at the CreateDB SQL file and click Open or OK, depending on your operating system. And I just realized you probably didn't see that because the screen is too big. So let me bring it down to size. So you go into the CreateDB folder and you select createdb.sql and you click Open. And this file name shows up on the page. It's all you really should have to do here. Go down, click the Go button, and it should come up with the message that looks like this. Import has been successfully finished. 28 queries executed. Now, if you look on the left side here, you'll notice something interesting. You see the word My here, right? And if you expand it, then you see guitar. And if you expand that, you'll see the 2 databases. It turns out when you define your database with underscores like this, it basically creates a folder structure in this tree view over here. So my underscore guitar gives you 2 levels down. It's the my level, the guitar level, and then there's the 1 and 2 for the database names. So that's something that I guess it's a feature of phpMyAdmin that it does that. This is the first time I've seen that, so I guess this is probably a new feature in the latest version, but if you're looking for your databases after you import, look for the word my, and then drop that down, and then drop down guitar, and then you'll see the databases show up. And you should be able to click on a database, and if you say you wanted to browse the categories table, you go to it and click browse, and it should show you the categories. Of course, there are only 3. Once you're able to do that, then what we want to do is we want to run this Book Apps Chapter 4 Product Manager application. I'm sorry, the viewer. We want to do the viewer first. So this guy right here, you want to run him. Now I created a folder called Lesson Examples, as you can see here, and I put the two. I just basically made copies of the folders because I wanted to make a few changes to the files and show you a couple things by formatting them differently. So I did that, and those are here under Lesson Examples. And what you can do is you go to your browser, and let me just back this up a minute here. So you go to localhost, and then now you go replace XAMPP with CO241, and then go to Lesson Examples, Product Viewer, and this is what you should see when the page comes up. Notice a list of products, the code, the name, and the price. And if you click these categories here, the appropriate category shows up along with the products that belong to that category. And that's what this application does. That's all it does. Notice, as you're clicking these categories, up here at the top, at your address bar, notice the category ID equals 2 and 3 and 1. What they're doing here is they're using the get attribute for posting to a web page. Whenever you put a URL in with a question mark and an attribute equals a value, you can read that through the get superglobal in PHP. Now forms can use get or post. This works with a get method. You never want to do this to transfer secure data across the web, because this is a URL that can be easily seen by anybody who has the technology to do it. So you never want to transmit like a credit card or anything secure. In this particular case, this is safe to do because the IDs are just numbers, and you can't really damage anything by doing this. So remember what this is doing here with this category ID, because what I'm going to do now is go into IntelliJ, and what I did here is I created a couple of projects and basically just took the files and brought them in to IntelliJ. And so here are the 4 files that are part of the viewer application. Of course, you have your style sheet, which I'm not going to talk about here at this point. But you have your index. This is the home page here. So notice what you have here when this thing runs. It starts out in HTML. Let me go to the top here. Sorry about that. Here's the top, okay? So it doesn't start in HTML. It starts in PHP. Right off the bat, you're in PHP mode. This line 3 right here, it says require once, and then it gives it a file name. This essentially takes you to the database.php file and runs whatever is in here. And when it's finished, it comes back to index and goes on its way from there. Now require once means that this will only run once in a particular document. So index.php can only do this link to this other file one time. This is an important file here because what this does is it connects you to your database. And you'll notice here there are 3 pieces of information that are needed to connect. The DSN, which is the database server name, the username, and the password. The DSN will be just like you see it here. The only thing that will change is the database name for your applications. But it'll start with mysql:/host equals localhost. Then DB name will equal whatever database you're trying to hook to. The username and password. Now, why are we using these? Well, if you look at the create DB file that was run, that you ran earlier, we're looking, of course, here at SQL, and you'll notice that if the database already exists, it deletes it. So it recreates My Guitar Shop 1. And it creates your tables. Here are your 3 create commands for your tables. Here you are inserting values into categories and products. It doesn't do anything with orders yet. Now, if you look here, what you're doing right here on line 49 through is you're creating a user. This user is called MGS_user. You're creating this user on the local host, which is the server. So this is saying go to the database server, which is called localhost, and make this user MGS_user. It's identified by password, so this is the password for the user here. These are the permissions that you're granting that user for this database. .star means every table in the database. So what this is basically saying is create a user called MGS_user. Create this user on the localhost server, which is our database server, also happens to be our web server. This user has a password of PA55 word. This user has select, insert, delete, and update privileges on the My Guitar Shop 1 database, and those rights are granted for all the tables in that database. Furthermore, the user MGS_tester is going to be created. That's another user. This user only has select rights on the products table. So if you think about it, MGS_user has the ability to do a lot. It can select, which means you can run queries, but they also have the ability to add records, delete records, and change records. So that definitely would qualify as a power user. This guy here, tester, can only run select queries on one specific table. So much more restricted capabilities for this user than for this user. With that in mind, let me go back here to our code. So, what we're saying here is we want to use the power user, and here's his password, and we're going to try to make a new PDO object. A PDO object will connect you to the database, and you pass to it through its constructor these 3 parameters. If it succeeds, it will store a reference to the object in $db, and $db will be the hook or the gateway into the database throughout the entire application from this point forward. This is built inside of a try-catch block, because if anything goes wrong with this instantiation of the PDO object, an exception will be thrown, and immediately caught on line 11. This exception will be a PDO exception. We're going to call it E, and we're going to get from E an error message by calling getMessage. We're going to store that error message in this variable, and we're going to include databaseerror.php, which basically goes over to this file, takes all this code, and plugs it in right here. Exit means that the PHP interpreter is finished. So remember, we started out from the very beginning on our home page, index.php. The very first thing it did was it brought in database.php. Took us here. We have all this code. We try to connect. If we fail, we get an error message. And we include this file, which produces a bunch of HTML, and it produces a complete web page here. So because of that, we don't want to go any further with our original plan of showing our home page index.php. So once we're done including this web page, we want to exit the PHP processor so that it doesn't proceed to bring up our index.php page. So index pulls in database, database pulls in database error if an error occurs. If an error occurs, as you can see here, there's HTML code to explain to the user something went wrong, and the specific error message is echoed out by again breaking into PHP at this point and displaying that error message to the user. However, if everything goes well, this instantiated object on line 9 will be successfully constructed, will be assigned to the DB variable, will not throw an exception, will not enter into the catch block, and we'll go back over to our home page and proceed down from there. So what are we doing? Well, we're going to make an attempt to get a category ID. We're going to use filter input. We're going to take a look at the get superglobal, and we're going to look for a category ID, and we're going to validate this as an integer. So what we're looking for is something in our URL like this after a question mark. We're looking for this with a number here that doesn't have to be 1. It could be anything. Now, if it can't find this, category ID will be null. No, I'm sorry, it will be false. It will be false, okay? If it does find it, but it can't validate the value as an integer, which could happen if you do gibberish like this. See now, it's trying to read that value as an integer, and it can't. If that occurs, category ID will be false. So it's either going to be null, false, or it's going to hold a valid value within it. You should never have a problem failing to validate your category ID if you stick within the confines of your website. But if you come up here, there's nothing to prevent you from coming up here and altering the address. You shouldn't. There's no need to, but if you do, you want to make sure your app can handle it. And it does, because what it does is if you do the gibberish thing, it won't be able to validate, and category ID will be set to false. If nothing's there, it will be set to null. In either case, if it's null or false, this if statement will set the category to 1. So what that basically means is if you do something like this, or if it's not there at all, your category ID will default to 1, which is the first category, guitars. So that's a pretty standard way of connecting and producing a default value for a scenario like this. So what's going to happen next is we're going to write a query here. A select query, very simple. Select star from categories. This is our table where the category ID equals this guy. Now this guy here is a parameter. And this query is called a parameterized query because it's not complete. It starts out great, but when it gets to this point, the colon there basically says, okay, we don't know what this is. We need to find it. It needs to be provided, okay? And we're going to have to get that value, and it's going to have to be bound to our statement. Now, the colon labels it. So when you look here at line 11, statement 1, which is your SQL statement, you're going to call your DB object and you're going to run the prepare method. You're going to prepare this query to be executed. It can't be executed, however, until you bind a value to the category ID label, and you're going to do that here on line 12. You're going to bind the category ID to the actual value that's stored in this variable, which in this case would be a 1 as the default. So once you create the string, pass it to prepare the query, and then bind any parameterized queries to the query, then you can execute the query. Now, the query will run and it will either give you no records or potentially many, or potentially 1. In this case, we expect it to either give us nothing back or 1 back. And quite frankly, we don't, if the user behaves themselves and just does what they're supposed to do, it's going to be 1, 2, or 3. Now if they come up here and they put an 8 in there just for fun, notice how it comes up with nothing. Well, why is that? Well, that's because it's going to look for categories where the ID equals 8. And when it executes the query, there won't be anything in it. The result will be 0 records back. This app doesn't really account for that. If there's nothing coming back, it tries to fetch the first record coming back. We're assuming there's only going to be 1 record coming back. But there may not be anything coming back. And if nothing is coming back, then fetch will return null, and category will be equal to null. So our category name will be equal to null because category, this array, is null. Now what happens is this select star from categories is going to select a record. And the record it's going to select is coming from the categories table. The categories table has 2 fields in it, a category ID and a category name. So what it's going to do, it's going to execute this query and it's going to return back the result set in statement 1. It's buried inside of the statement 1 object. When you call statement 1 fetch, so when you call the fetch method, it's going to fetch the first record only. If you call fetch again, it'll go and grab the second record, and the third record, and the fourth, and so forth. But the first time you call it, it's going to grab that first record, if it exists. Now if we put 8 in a bogus category, that record there's nothing even in there at all. And fetch will return back null. If there is a record, fetch will return it back. And what it does is it takes the row or record and it creates an array. There's 2 fields, so it creates an array of 2 elements. That array is stored in this category variable. And as you can see here, we're taking the array and we're accessing by name the element category name. So the array holds 1 record's worth of data. It's a one-dimensional array composed of 2 elements. The first element is the category name. The second, I'm sorry, that's not true. The first element is the category ID. The second is the category name. So we are after the category name here. I could have put a 1 here instead of the string, which would get the second element, or 0 would get the first element. So you can use ordinals, which are numbers, or you can use literal strings, which map to the ordinals, which map to the correct element. So this essentially goes into the array, looks for the element whose name is category name, takes what's in it, and stores it in this variable right here. Now, if category ends up being null, this line right here will be null. Our category name will be empty. Now, what does close cursor do? A cursor is a very angry database manager. No, I'm just kidding. A cursor is a manager of a record set. And a cursor manages the traversal of the record set. So if you have a record set that comes back, like down here where you do a fetch all, okay, you're selecting from the categories table. This time you're getting all the categories and you're sorting them by their ID. In that particular case, when you execute the query, it's going to generate a list of records. Fetch all gets all of them. And the cursor reads them out one by one and puts them into a 2-dimensional array called categories. The first dimension holds the record number or row, and the second dimension holds the columns. That's for this one. For the one we're in up here, it's simpler because we only get 1 record because we're calling fetch. Fetch gets the first record the first time you call it, and the second time you call it, it gets the second record, and so on. Well, how does it know the second time you call it to get the second record? It knows that because the cursor manages that. So what we're doing is we're closing the cursor so that we can clear out the memory that it used and reset the cursor system for the next thing that's coming. Now, that's all handled with statement 1. Notice statement 1 is not just a string. It's not a string, actually. Statement 1 is a record set which may only have 1 record in it, or even 0. That record set we're fetching from here, and we're pulling out a record from the set, and in this case the only record in the set. Now when you get down into this next query, as I said, the query string gives you all the categories. There are no parameters in this query like there were up here, so you build the string, you pass it to the prepare method of the database, and then you simply execute the query. And this one, notice, is called statement 2. Statement 2 is a record set. Fetch all grabs all the records, and as I said earlier, it puts them into categories, which will be a 2-dimensional array. And we've got that. Now here, we're going to select every field from the products table where the category ID equals that parameter. And we're going to order by product ID. So here's what's going on. When you pick a category like drums, it's only going to show the products in that category. So here, it's going to select all the products where the category is equal to the drums category, which is a number because that's used as a foreign key, and that number is plugged in right here where you bind the category ID into the query and then execute. This will come up with a list of product records. Fetch all will pull them all into products. Products will be a two-dimensional array. The first dimension will hold the records. The second dimension will hold another array that contains all of the columns. So all of this collects up our data, essentially, and it puts them into these arrays for us. Once we have all the data, now it's time to display all of it. So we get out of PHP, we switch into HTML, and we do all of our HTML. We're going to show a list of categories on the left. So that's preparing these things over here, this left side. Notice, and this is a really cool new functionality in PHP that they've added recently, you are going to create an unordered list, and this unordered list has a series of li tags, as you know, and each li tag is going to be a link taking you to question mark category ID equals, and then in PHP you're going to echo out from the category array, grabbing the category ID, and that number will get stored into this string. Well, where is category coming from? Well, check out this for each loop. What's going on here is it's looking at all the categories in that two-dimensional array, and it's pulling them out one at a time. So if you've got 3 categories, this loop will run 3 times. It takes the first category and it calls it $category. And you can say to that category, what's your ID? And echo it out. Then it loops back up. Notice here's the end of the loop, so this entire loop is right here. So it comes back up, grabs the second category, calls it $category, and it spits out another link with category ID equal to 2. Then it shows the name of the category, and then it closes the A tag. So you're getting an opening A tag, href equals question mark category ID equals some number, closing bracket, the name of the category, closing bracket, closing tag for your A tag here. So opening tag A, href equals category ID equals something, space, closing bracket, content would be the name of the category, and then a closing A tag, closing li tag, and then you loop back up and go to the next category. And in doing so, you will generate this list of categories. If you look at the source code for this page, you see here what it's doing. It's A href equals question mark category ID equals 1, and then the name of the category is guitars. And then it does this for all the categories. It repeats this structure 3 times in our case. It follows it up with a closeout of the UL list, closeout of the nav bar. Now the style sheet is responsible for making it look the way it does. And if you've taken 148, you learned how you can use an unordered list by styling it to appear as a vertical set of links like it does here. Then we go into the next section over on the right. We create an H2 header. We display the name of the category, which is this right here, drums. We create a table. We create the first row, which says code, name, and price. Class equals right is a style that puts it right justified. Now check this out. Here's another loop. We're going to go into the products array, which remember it was two-dimensional because it has more than one product in it. It grabs the first product out, echoes the code and the name into these TD tags. As you can see, the code and the name. And then it echoes out the price. So each one of these fields is stored in an element of the product array. So again, products is composed of an array of arrays. It's an array of arrays, okay? The first element has an array in it. The first element in products is the first record in the product table, which has a category ID equal to whatever the user is asking for. Product is one specific record in that record set. In here in the array, it's a specific element in the array. But product itself is an array. So once you get the product variable, it is also an array, and you can iterate into it by its fields. So products essentially is the set of records, and product is a specific record, and in the loop it takes them one at a time from top to bottom. Now, if that makes sense to you, congratulations, because this is a little bit tricky to wrap your mind around when you first see it. But that's how you get a table into PHP, storing it into memory. You do it by using arrays. So if you're not real comfortable with arrays, you might want to just brush up on them in terms of multi-dimension arrays in this case. But be that as it may, this is all wrap-up stuff here, and that's the end of the PHP file, thus giving you this page. And again, if you click the items, it reloads the page with the appropriate ID, and on it goes from there. So that's the first example they show. Now I don't know if what I've done here is helping at all in terms of explaining this. Hopefully it's helping you to make sense of this, but that's what's going on. So the next part of the chapter gets you into this product manager example, which is similar, but it also gives you the ability to delete a product, add a product, or list the categories. So we'll talk more about this one in the next video, right? I think we've had enough fun for this video, so I'll cover that in the next one, but hopefully this will help make some sense out of what's going on, at least in this first example. So we'll catch you in the next part for the next application in Chapter 4. We'll see you then.